All right, so we're starting Unit 5, and this has it's a good unit. I really enjoy it. It's some of my favorite stuff, but it starts off with radicals. Okay, so we've done some stuff with radicals, and if you keep watching, we're gonna, actually, let's stop. I'm gonna stop. Before we get into it, let's talk about perfect squares. So perfect squares are, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 is 36, 7 49, 8 64, 9 81, 10 is 100, 11 121, 12 is 144, 13 is 169, 14 is 196, and 15 is 225. And there are more. If you're in my classroom, they're actually at the top of the board. It says perfect squares, so you can look there. So we've done some stuff with perfect squares, so there's more that we're going to do, but I'm going to stop with the perfect squares. So let's recap on how to do a square root. So the square root of 16 is you're thinking, what number to the second power equals 16? And the answer is 4, right? Because 4 times 4 equals 16. Is there another number? The answer is yes. You could also say -4, because -4 times -4 is positive 16. So the most accurate way to write this would be, if you remember from last semester, is plus or minus 4. Okay, so anytime you have a square root, you're going to have plus or minus. I'm not going to hammer it so much at the beginning of this unit, but towards the end it does come into play. So if you would like to get in the habit of, whenever you take square roots, of putting the plus or minus sign, that would be a great idea, but I'm not going to dock you points on your quiz in the meantime, because it's a kind of a minimal thing, but it is kind of a good habit to get into. Okay, so now we have square root of 8. 8 is not a perfect square. It's not on that chart we just filled out, but it does break up. Remember, you have to see if any of those perfect squares goes evenly into it, and this breaks up into 4 and 2. And how I do this is whenever so you can take the square root of 4, so I cross it off, and I get the square root of 4 is 2. You can't do anything with the square root of 2. You can't break it apart. It's an irrational number if you write it in your calculator. So it is 2 square roots of 2. Okay, now I'm going to freak you out and throw a variable at you. So the square root of x squared, what would that be? Well, that's just x, right? Because the square root and the second power cancel each other out, and you just get x, right? Okay. Now, x to the 4th, what would this be? Well, this breaks up into square root of x squared times the square root of x squared, right? The square root of x squared, I like to cross them off, and that gives you x and x. So now we have x times x, which gives you x to the second power. Okay. Now, x to the 3rd power, this one's a little different. So I'm going to break this up into things that do have perfect squares. So this would be like x squared, and then you have 1 x left over because there's 3 total. So the square root of x squared is x, and you can't break apart the square root of x, so I'm just going to drop it down, and that would give you x square root of x. One more of these, so this would be x to the 5th. So this is actually going to break up into 3 things. So it's going to, I always write it out as x squared, as many times as I need, and then we just have a solo x left. Okay, so square root of x squared, that's going to be x. Again, x. And that one you can't do anything with. So let's put it all together. I have x times x, which is x to the 2nd power, and then square root of x. And one thing to notice, you always write the square root second, and the number, whenever it is not square rooted, is out front. That's kind of the math etiquette way to write it. Okay, I'm gonna skip those for a second. Let's do some problem. Let's practice. Okay, square root of 25. 25 is a perfect square, so that would just give me 5. All right, 48. Which perfect square goes into 48? So there's a couple different ways to look at this, and I'll show you each one. So what's going to be tricky on this unit is you will not have a calculator for certain portions, and this is one of those portions. Okay, so you're going to have to be able to do this with mental math. So 48 breaks up into, some of you, there's two different ways you can look at it. I'm going to do the longer way first. So you could think, okay, 4 goes into it. 4 is a perfect square. So it'll be 4 times 12, right? What is the square root of 4? Well, that's 2. Okay, so it would be 2 square roots of 12, but you can break apart 12. So square root of 12 breaks up into square root of 4, square root of 3. Square root of 4 is 2. So then I have 2 times 2 and the square root of 3, so that would give me 4 square roots of 3. Okay, another way to look at this is square root of 48 breaks up into, if you didn't, this is a bigger number, so 16 times 3 is 48. Actually, this is a good one to memorize. It comes up a lot. So square root of 16 times 3, so square root of 16 is 4. And you just drop down the square root of 3. And you can see I get the same answer. So it's just like whenever you're reducing fractions, if you can do it by smaller numbers, but you might have to do it multiple times. If you're lucky enough to pick the biggest number first, then you have to do it less times. Okay, now, freak out. So I gave you a number and a variable. Okay, so this breaks up into square root of 16 and the square root of x to the 4th, right? And so square root of 16, that's easy. We can do that. That's 4. Cool. Square root of x squared breaks up into, or x to the 4th breaks up into square root of x squared twice, right? Because there's 4 of them, so 2 and 2. All right. This becomes x. This becomes x. Looks like all of our square roots have disappeared. Great. So we have 4 x to the 2nd power, because x times x is x squared. Okay, let me give you a fraction now, really mess with you. Okay, whenever you have a fraction like this, you can break it all up into piece by piece. So this breaks up into square root of 16 times the square root of y squared over square root of 144 square root of z to the 4th. Okay, so square root of 16 is going to give me 4. Square root of 144 is going to give me 12. Square root of y squared is y. And the square root of z to the 4th, just like x to the 4th, is going to end up giving me z squared. If you wanted to write it out, you could. It would look like this. And so that would be z, which is z squared, and it's on the denominator. Okay, so now are we finished? The answer is no, but we are close. So 4 and 12 simplifies to 1 over 3. So your final answer is y over 3z squared. Okay. All right, so now we're going to go back up here. Sorry, this video is long. Oh, sorry, wrong part. Now we're going to talk about cube roots. So you've done square roots before, but I don't think you've ever done cube roots. So let's first identify what the perfect cubes are. 2 to the 3rd power is 8. So it's like 2 times 2 times 2, which is 8. 3 to the 3rd is 27. 4 to the 3rd is 64. 5 to the 3rd is 125, and 6 to the 3rd is 216. So sometimes the numbers will get a little bit bigger, but kind of that's where in the ballpark I'm going to stay. So try, if I were you, I would try to memorize these numbers, or if you don't, you might have to do at the very beginning of your quiz or your test, I might take the time to work those out and just have them on the side of my paper so I can reference, and it'll speed things up later. Okay, so now let's talk about cube roots and keep those in mind. So go back up here. So the cube root of 27. So cube root, notice has a little 3 right there. So this is saying what to the third power is 27. Okay, and we know that's 3, right? Because 3 times 3 times 3, okay, is 27. So this answer is 3. Okay, let's talk about the plus or minus thing that we did on the last one. So could it be plus or minus 3? Well, we know positive 3 works. What about negative 3? So negative 3 times negative 3 times negative 3, does that give me 27? Well, this would give me, these two would give me positive 9 times negative 3, which would be negative 27. So for this one, for cube roots, the negative, there is no plus or minus. It's either positive or negative. Okay? All right, let's do another one. Cube root of 16. 16 is not on that cube root list. Don't think 4, because we're talking about cube roots, not square roots. Switch gears in your mind. So now cube roots, only to the third power. Do any of those cube roots go evenly into 16? And the answer is yes. 18 does. Or sorry, 8 does, not 18. 8 times 2, so you could break this up as the cube root of 8 times the cube root of 2. What is the cube root of 8? Well, that is 2 cube roots of 2. All right, and so we can't break that up anymore, so you're done. All right, let's do a variable. What do you think the cube root of x to the third is? Well, cube roots and third powers cancel each other out, and you just have x. So then cube root of x to the sixth would break up into the cube root of x to the third, cube root of x to the third. That gives you x times x, which is x squared. A couple more. So we have cube root of x to the fourth breaks up into cube root of x to the third. I always try to do it in stuff that you can root. And looks like there's one left over, so I'm just going to write a solo one off to the side. So this would be x, because you could take the root of that. You can't do the other one, so you just drop it down. So it's x cube root of x. One more of these. X to the seventh is actually going to break up into 3 things. So it'll be the cube root of x to the third, cube root of x to the third. There's 6 of them, and I need one more left over, so to make the 7th. So this is x, this is x. Put it all together. This would be x squared cube root of x. Okay, let's do some more practice. And I know this stuff is weird, you just have to get used to it. Oh, one more thing I'm going to talk about. If you see more about the plus or minus. So the cube root of 8, we said, is 2. Sometimes they're going to do negative cube root of 8. They put the negative outside. So you would do negative, because that negative right there. And order of operations says you take the cube root first. So the cube root of 8 we just said is 2. So this would be negative times 2, which would just give you negative 2. Another one would be, they'll write it like this sometimes, the cube root of negative 8. So it's saying what to the third power equals negative 8? Well, that would be negative 2. So negative 2 times negative 2 times negative 2. So that's still negative 2. So either one of these 2 ways is how they're going to write it in order to get a negative answer. So just be prepared. They can put the negative inside or outside on cube roots, and it's fine. Either way works. Okay, so back at this. What is the cube root of 27? We already did this one, right? It is 3. Oops. So 3. Easy. Cube root of negative 64. So we know there's going to be a negative on it, so I'm just going to put that down. What's the cube root of 64? 4. Okay, I gave you a fraction and a negative just to freak you out. So we know there's going to be a negative in our answer. So I'm just going to put that out there. Then remember, you can break this up as 27. Let's change this to 216. So, sorry, change that problem to, instead of 343, do it to 216. So the cube root of 27 over the cube root of 216. So this would give you negative, don't forget the negative. Cube root of 27 is 3 over 6. Are you done? No way, you got to reduce that, and it becomes negative 1/2. Okay, 128 is not a perfect cube. One of them breaks into it evenly. So try, I'll just tell you what it is to kind of speed up time. There's a few different ways you could do it. I think 8 goes into it. But actually, it's the cube root of 64 and the cube root of 2. This is another really popular problem. So, because 2 times 64 is 128. So, this cube root of 64 is 4. Can't do anything with cube root of 2, so just drop it down. Alrighty, now let's do some numbers. Okay, so numbers and variables, break it up, break everything up. So I've got cube root of 16, cube root of x to the 3rd, cube root of y to the 6th, cube root of z. Okay, 16 is not a perfect cube, so break it up into cube root of 8, cube root of 2. That ends up being, cube root of 8 is 2, so I'm going to drop that down. Cube root of x to the 3rd, that's just x, right? And again, I like to cross them off as I go. It kind of helps me see it visually. Cube root of y to the 6th breaks up into y to the 3rd, y to the 3rd, which is y and y. And you can't break up cube root of z, so there's nothing you can do with it. All right, so now you have the following. You have 2 times x times y times the cube root of 2. I'll do this. Times the cube root of z. All right, let's put it all together. So when you're doing this, all the numbers out front, you can combine anything you can. Looks like the only thing out front I can combine are the y's. So this would be 2x y squared. And now, since these are both cube roots, just like before when we took them apart, now we're going to put them together. So you would write them together. So this would be the cube root of 2z. And also make sure that your little tail of your root, the top of it, covers both numbers. You don't want to write it as this because it's not being rooted. So make sure that z tail covers both numbers. Okay, so can we combine anything else? I don't believe so. So that's your answer. All right, now the last thing we're going to do is quad roots. So it's saying to the 4th power. So these don't come up a lot because they can get out of hand in really big numbers really fast. But 2 to the 4th is like 2 times 2 times 2 times 4 times. I think I might have said it too many times, whatever. So that would give you 16. And 3 to the 4th is going to give you 81. So those two I would definitely memorize or just get used to having to work them out. Okay, so quad roots. Quad root, or the 4th root of 80. So we're going to break it up. Oh, why did I put 3rd root? 4th root of 81 over the 4th root of 16. 4th root of 81 is 3 over the 4th root of 16 is 2. Can't reduce it, so that's it. Okay, 2 more. So we've got, I'm going to break it up in the fourth root of 81, the fourth root of x to the fourth. What's the fourth root of 81? That's 3. Can you take the fourth root of x to the fourth? You sure can. The fourth root and the exponent cancel each other out, and you just have x. So your answer is 3x. I kind of spaced that out. It's okay. Last one, break it apart. So we have the fourth root of x to the 8th, fourth root of y to the 4th. X to the 8th breaks up into fourth root of x to the 4th, fourth root of x to the 4th. So that would give me x, and the fourth root of y to the 4th is y. Put it all together, be x squared y. And that is it for the intro to radicals. We're going to do more with them later, but I hope you enjoyed. Make sure you do your homework so you practice this stuff because it is weird. Thanks for watching. Have a good day.